Hello guys, welcome back to our channel, The IT Man, and let's solve problem of the day today, balance a binary search tree. Okay, so we are given a root and we have to return a balanced binary search tree from a binary search tree. Okay, so here is an example 1, 2, 3, 4, and this is the subsequent balanced binary search tree. Okay, so let's understand the concept a bit more. So, what is a BST? What is a BST? So, a BST is a tree which ensures one property, that if this is a root, then the right value, right? The right side subtree has all the values which is greater than root, okay? And the left subtree has all the values which is less than root. This is the primary property which which if a tree follows, then it will be called as a binary search tree. Okay, and what is a balanced tree? Okay, so let's say I have a tree. Okay, I have one element here and two elements here. So what is the height of the left subtree? It's 1. What is the height of the right subtree? It's 2, right? So if the left subtree height minus the right subtree height is at max 1, so it can be 0 or 1. If it lies in this range, then we can call it as a balanced tree. Okay, and of course if say let's say if the height is more than that, so let's say if a tree looks something like this, okay, then this is not a balanced tree because here the height difference is 2. Okay, so according to the definition it should be 0 or 1, then only we can call it a balanced. So now we have to return a balanced binary search tree. Okay, so let's take the example given. So we have 1, 2, 3 and 4. Okay, so now what could be the possible conversion, right? One is this, like if I keep a 2 here, then first is I have to make sure the property is preserved, the left is smaller and the right elements are greater. Okay, and this property needs to be followed at every subtree level. Okay, so this is one possible combination and this is one possible combination, right? These are the two. So according to the question, we can return any of the valid combinations because I'm sure there is no specific one single answer. We just need to have one, we have to reach to one valid answer. Okay, now let's try to think of the approach. Cool. So we know that it follows one property, that the in order traversal, right? The in order traversal of a of a binary search tree is always sorted. Okay, so in order is left, root and right. Okay, in order is left, root and right, and if we traverse a binary search tree, this will always return me a sorted tree in sorted elements order. So this is one property we can take into account. Second is that the middle element always has left less than it and right greater than it. Okay, so the mid value lies in between the range of left and right. Okay, these are the two properties we can utilize to solve this question. Okay, so what I can do to solve this question is, so step 1, find the in order traversal, right? So if I find the in order traversal, basically I'll have a sorted list of elements, whatever is present in the BST. Okay, second is I can, for every recursive call I make, I can take the mid element, right? I can take the mid element, assign it as root, right? And then recursively call that function for low to mid minus 1, and for the left value, and for the right value I can call it as mid plus 1 to high. Okay, and I can keep making my uh, tree. So let's understand it with some one simple example. So let's say I have a BST, and when I traverse it, I get elements in this order. Okay, a sorted order. Fair enough. Okay, so going by the logic we just explained, let's say oh, you know what, I'll just keep it 5. Yeah, cool. So let's say I take the middle element, right? I assign 3 as my root, and I recursively call the function over this subset and this subset. Cool. So now when I go to the left function call, uh, what would be the middle element? So it's 0 plus 1. So actually the middle element will be 2 in this case. Okay, and in this case this will come as 5. Okay, now again this will recursively call it for the next value, so this will be just 1. Okay, and again finally it will be also assigned, and see, we have a balanced binary search tree. So this is pretty much the logic for this question. Let's try to code it so that we have a better idea of how to implement this solution. Okay, cool. So let's say I will declare something called as maybe sorted answer. Okay, to store all the elements I'll be receiving after the in order traversal. Let's quickly define a function in order traversal. Okay, and I'll pass root. Cool. Now the base case, if root is none, I'll simply return, else I'll follow the in order, which is left the element and right. Cool. So this is my in order traversal function, and yep, I think it looks good. So I'll just call in order traversal of root here. Oh, by the way, sorry, this is in order traversal, not just in order. Okay, yep, I think now it looks good. Okay, now I have the in order traversal. Now let's create the tree. Okay, let's create the tree. Let's say I'll store the length of my sorted answer in a variable called as n. Okay, now I have to make I'll just declare a function, which will be getting recursively called. Make tree, and I'll pass it a low value and a high value. Let's calculate the mid. Oh, but before that, let me put the base condition. If low is greater than high, simply return. Okay, the base condition is set. Let's just quickly do the mid. Low plus high integer division 2, and let's start making a new balanced BST. Sorted answer at mid. Okay, so we have got a root. Now we recursively need to call it to make the left and right subtrees. Root dot left equals to make tree. plus 1 to high, and finally we will return the root. Okay, and here I'll return made tree 0 to n minus 1. Okay, I think the code looks good. So we created a sorted answer, we did an in order traversal, and then we stored it in a sorted answer list. Finally, we wrote the function to do the recursive call and make a new balanced BST. Let's try. It shows, oh, I am so sorry. If okay, okay, great, it works. So yeah, this is the code. Do let me know how you feel about it, and do like, share and subscribe our channel if you find our content useful. Thank you.